All right, hello pre-calc students, Mr. Lowell here, walking you through the rational functions, my open math. Had an error where it said I automatically reattempted the questions, so I'm just redoing the problem. Starting, I had an error with question 7 on how the question read out. So I'm going to solve all the problems as if I'm doing for the first time. So problem 1, 2x over 7x plus 8. Multiply each side by 7x plus 8, so I have multiply the left side by 7x plus 8, multiply the right side by 7x plus 8. The 7x plus 8's cancel out, and you get 2x is equal to 1 times 7x plus 8. So I have 2x equals 7x plus 8. I subtract 2x from each side. 0 is equal to 5x plus 8. Negative 8 is equal to 5x. Negative 8 fifths is equal to x. And that is our solution. Question 2. So first we find vertical asymptotes and holes. Nothing cancels out here. This does not, numerator denominator do not factor, nothing cancels out. So we just have vertical asymptotes. We have a vertical asymptote and not a hole because we have a denominator that does not cancel out. We find a vertical asymptote, the x value that makes the denominator equal to 0. So 4x minus 9 is equal to 0. 4x is equal to 9. 4x is equal to 9. Sorry. If 4x is equal to 9, then x is equal to 9/4, and because that does not cancel out, this is our vertical asymptote, and the vertical asymptote is always a domain restriction. That is a domain restriction. So that being said, x equals 9/4, so that is a domain restriction. So our inner domain is from negative infinity to 9/4 union 9/4 to infinity. The y-intercept is the y value when x is equal to 0. So if x is equal to 0, you have 0 plus 6 over 4 times 0 minus 9. That's going to simplify to 6 over negative 9, which is going to simplify to negative 2/3. So our y-intercept is 0, negative 2/3. The x-intercept is the value when y is equal to 0. So if y is equal to 0, you have 0 is equal to 4x minus 9. You multiply each side by 4x minus 9. Multiply the left side. Multiply the right side. On the right side, the numerator and denominator cancel out. Anything times 0 is 0. So on the left side, you're left with 0. So you have 0 is equal to x plus 6. 0 equals x plus 6. Subtract 6 from each side. X is equal to negative 6. All right. Now, vertical asymptote. X is equal to 9/4 and y is equal to 1/4. All right. How do we find the vertical asymptote? Well, we just found the vertical asymptote right here. That's x equal to 9/4, so we solved that first. The horizontal asymptote is y is equal to 1/4. If our degree for the numerator is the same as our degree for the denominator, x to the 1, 4x to the 1, then your horizontal asymptote is the ratio of your leading coefficients. So here, the leading coefficient is 1x to the 1 over 4x to the 1. So our leading coefficient over leading coefficient, that's 1 over 4. So horizontal asymptote is y is equal to 1/4. That's question 2. Question 3. The y-intercept is at y is equal to negative 5. The y-intercept is when the x values are 0. So when x is equal to 0, this value is 0, this value is 0, this value is 0, this value is 0, and you have negative 15 divided by 3, and that's going to be equal to negative 5. The x roots a and b, where a is less than b. You have a is equal to negative 5/3, b is equal to 3. So how do I find that out? Roots are when x values are equal to 0. Sorry, roots are when the y value is equal to 0. So when the y value is equal to 0, I multiply the right-hand side by 2x squared plus 7x plus 3, and the left-hand side by 2x squared plus 7x plus 3, but it doesn't matter because it cancels out on the right-hand side, and 0 times anything is 0. So I ended up with 0 is equal to 3x squared minus 4x minus 15, and this is going to factor into 3x. I need two terms that multiply to negative 15 and have combined with the 3x and the x to add to 4x. So that's going to be 3x how will this? I know 4 times 3 is 4x minus 5, 3x minus. Oh, okay. You have x minus 3 and 3x plus 5. That way, 3x times negative 3 is negative 9x. 5 times x is plus 5x. Negative 9x plus 5x is negative 4x. So 3x plus 5x minus 3. So our roots are going to be the values that make this equal to 0, because remember, we factored this, so this is equal to 0. So we have 3x plus 5 equals 0. 3x plus 5 is equal to 0. 3x is equal to negative 5. X is equal to negative 5/3. And x minus 3 is equal to 0. X is equal to 3. So that's 2 for this problem. Okay. 3 are vertical asymptotes. So now we have to factor our denominator. This is going to be 2x and x. And note that this is just fortunate that nothing cancels out here. If values cancel out, we'd have a whole. So we need values that multiply to 3 and add to 7. That's going to be x plus 3, 2x plus 1. 2x times x is 2x squared. 2x times 3 is 6x. 1 plus x is x. 6x plus x is 7x. 1 times 3 is 3. So these are the values that make our values equal to 0. So you have 2x plus 1 is equal to 0. So 2x is equal to negative 1. X is equal to negative 1/2. And x plus 3 is equal to 0. X is equal to negative 3. So x is equal to negative 1/2. And x is equal to negative 3. Negative 3 is the smaller value, so that comes first. The horizontal asymptote is at 3/2. That's because our degree is the same for our highest degree term. So our degree is the leading coefficient. So we have a leading coefficient of 3 over 2, and that is our horizontal asymptote. Clear annotations. Question 4. Holes in vertical asymptotes. We have x squared plus 5x minus 14 over x squared plus 15x plus 56. We just need a factor. This will factor into x plus 7, x minus 2 over x plus 7 and x plus 8. 7 times 8 is 56, 7 plus 8 is 15, 7 times negative 2 is negative 14, 7 minus 2 is 5. And so this cancels out, so that's our whole. X plus 7 equals 0, x is equal to negative 7. And this does not cancel out, so it's a vertical asymptote. X plus 8 equals 0, x is equal to negative 8. That is our whole on a vertical asymptote. cancels out whole, doesn't cancel out vertical asymptote. Question 5. Need to get a common denominator here, so I multiply each side by this term by 3 because I'm getting a common denominator of 3x. 3 over 3 times negative 8 over x is equal to 5 over 3x plus 8 over 1 times 3x over 3x. So give me common denominator 3x. So I get negative 8 times 3, so that's negative 24 over 3x is equal to 5, 8 plus 24 over 3x. At this point, I can always cancel out my denominators by multiplying. Once I get a common denominator, I can cancel out by multiplying each side by 3x. So you get that's 5 plus 24x, because 8 times 3 is 24. So that's 3 times negative 8. That's negative 24 is equal to 5 plus 24x. So negative 24 is equal to 5 plus 24x. Negative 29 is equal to 24x. Subtract 5 from each side. And then divide each side by 24. X is equal to negative 29 divided by 24. So you just divide 24 from each side to isolate x. Negative 29 divided by 24. Question 6 can get kind of tricky. What I have to do here is 2 over 3x plus 3, 5 negative 5 halves, 3 over x plus 1. And I'm actually going to try to go for a common denominator of 6x plus 6. So I'm going to have 2 over 3x plus 3 times 2 over 2 is equal to 5 over 2 times 3x plus 3 over 3x plus 3 minus 3 over x plus 1 times 6 over 6, and this should give me 6 times 3 is 18, minus 5 times 3x plus 3, so minus 15x plus 15. 6 times x plus 1 is going to be 6x plus 6 over 2 times 3x plus 3 is 6x plus 6, which is equal to 2 times 2 is 4, so that's 4 over 6x plus 6. Now I have a common denominator, we can cancel that out. So that's negative 15x plus 15, so actually negative 15x minus 15 plus 18 is equal to 4. That's negative 15x is equal to here, let's simplify some steps here. And 15x plus 3 is equal to 4. So that means negative 15x is equal to, subtract 3 from each side, is equal to 1. So x is equal to negative 1 over 15, or 1 over negative 15. So that's our x value, and that is our correct answer. Moving on to question 7. X over x minus 3 minus 2 over x plus 2 equals 9x minus 12 over x squared minus x minus 6. We need to get a common denominator here. And this factors into x minus 3, x plus 2. So I have x over x minus 3, get a common denominator, multiplied by x plus 2 over x plus 2 minus 2 over x plus 2 times x minus 3 over x minus 3 is equal to, we already have this common denominator. That's 9x minus 12. 9x minus 12. That's equal to 9x minus 12 over x minus 3 times x plus 2. Now, I have a common denominator, so I can, well, it's combined like terms and cancel. This becomes x squared plus 2x minus 2 times x is 2x, 2 times negative 3 is minus 6, is equal to 9x minus 12. And at this point, I can cancel out my denominators. But I do want to make a note that x cannot equal 3 and x cannot equal negative 2. So x squared plus 2x minus 2x minus 6, that's just going to become x squared plus 6 equals 9x minus 12, which means x squared minus 9x plus 18 is equal to 0. So this term will factor into x minus 6, x minus 3, x minus 6, x minus 3. These are whether you're equal to 0. So x is equal to 6 and x is equal to 3. But wait a minute. X minus 3 is in the denominator. So x cannot equal 3. So x is equal to 3 is not a solution, and their only solution is x is equal to 6. All right, so our solution was x is equal to 6, and that's it. Clear annotations. Question 8. The oblique asymptote. The oblique asymptote is when you have a numerator degree larger than your denominator degree. All right, so your numerator degree is larger than your denominator degree. And at that point, you find your oblique asymptote via polynomial division. So let's find our oblique. You find your quotient. So let's find that oblique asymptote. We have negative 4x cubed minus x squared plus 2x plus 1 divided by 3x squared minus 3x plus 2. All right, 3x squared times x. So sorry. So we need to find terms that are going to multiply. So we have to do negative 4x cubed divided by 3x squared. So that's going to be negative 4/3 x. Negative 4/3 x. So that becomes negative 4/3 x becomes negative 4x cubed multiplying across here, times negative 3x times negative 4/3. It's going to be negative, that's positive 12/3 x. That's just going to be plus 4x squared. Plus 4x squared. And then plus 2, that's going to be negative 8/3 x. Minus 8/3 x. Okay, so parentheses, subtract. You have negative 4x cubed minus 4x cubed. So that's going to be 0. Negative x squared plus, so that's going to be negative 5x squared. And then I have 2x minus 8/3 x is 6/3 x plus 8/3 x is going to be 14/3 x plus 14/3 x plus 1. And so now I need to cancel out negative 5x squared, so that's going to be 3. So you have negative 5x squared divided by 3x squared, and that's just going to be equal to negative 5/3. So minus 5/3, that's going to be negative 5/3 times 3x squared, that's going to be negative 5x squared. Negative 5/3 times negative 3x, that's going to be positive 15/3 x, so plus 15/3 x, and negative 5/3 times 2, that's going to be minus 10/3. Parentheses, subtract. 0. 14/3 minus 15/3 is 1/3 x. 1 minus 10/3, so that's 3/3, plus 10/3, that's actually going to be 13/3. 1/3 x plus 13/3. This is messy. But our answer should be 4/3 x minus 5/3. Okay. Four-thirds x minus 5/3. All right, I'm not feeling too confident about this one. Okay, let's try. All right, so I apologize for making a mistake there. Let's enter negative 4x cubed plus 3x squared plus x plus 2 over 3x squared plus 2x minus 3. Oh, and sorry, let me copy this, Control C, Control V, Control C, Control V. All right, so we're looking at this function here. And so we have our oblique asymptote right here. Alright, I'm gonna factor this. That's gonna make life so much easier. 3x, and I'm going to minus 3, and so it's plus 1. No. That does not factor. Oh, no, x plus. No, you have to do plus 1 plus 1. So I just. What about you just do negative 4/3? 3x squared plus 2x minus 3. Negative 4x third plus 3x squared plus x plus 2. And what I'm going to do is 1/4 x. So 4x, negative 4x cubed over 3x squared. So is there an efficient way to find the oblique asymptote? Yes, so we have to do long division. So let's use long division. That's what. So that's equal to negative 4/3 x. Negative 4/3 x. Negative 4x cubed. Negative 4/3 x, that's minus 8/3. Minus 8 thirds x squared plus 4x minus plus 4x, subtract 0, 3x squared, that's 9/3 plus 8/3 is 17/3 x squared. And then that's minus 3x. Minus 3x plus 2. And then I have 3x squared. And I need to multiply to get 7. So you need to do 17 thirds x squared divided by 3x squared. So that's going to be plus 17, I guess. Yeah. Well, 17 divided by 3. So what times 3? X times 3 equals 17 over 3. Nine x is equal to 17. So x is equal to 17 ninths. Okay. So yeah, so that's 17 ninths plus 17 over 9. So that's 17 over 9 times 3x squared becomes 17 thirds x squared. 17 times 2 is 34 plus 34 ninths x minus 17 times 3 is 30, 21 minus 51 ninths. 0 minus 27 ninths plus 34, so that's plus 7 ninths x 18 minus 51. So it's actually, that's 18 ninths plus 51 ninths, so that's going to be plus 18 plus 51, that's 69 ninths. 69 ninths. This is such an ugly problem. Okay, so negative 4 thirds x plus 17 ninths. Okay, that's right. Sorry, I just wasn't feeling sure of myself. X minus 1. That's x minus 1 times x minus 1 times x minus 1. That should be a... It doesn't completely cancel out, so it's a vertical asymptote. That's because you have one more x minus 1 that doesn't cancel out. So here x minus 3, x equal to 3 is a whole because you have more in the numerator than the denominator. So it does completely cancel out. X equal to 6, that's a vertical asymptote because you don't completely cancel out. You have one uncanceled x minus 6 factor on the denominator. And x minus 8 over x minus 8, that's going to be a whole because the numerator and the denominator perfectly cancel out. That's question 9. Question 10. Select the graph of this function. So we have a vertical asymptote at 3 and negative 3 for all of them. So let's see, can we eliminate any answer choices? No. All right. Well, let's look at our horizontal asymptote. We have a horizontal asymptote at x is equal to 0. Because, well, yeah, degree is larger on the bottom. So we have a horizontal asymptote at x equals 0. So let's see, do we have any horizontal asymptotes at 0? Looks like we all do. So let's worst comes to worst, we can Desmos this. So we can look for x or y intercepts, but it'll just be faster to Desmos. -9 times times x minus 1 over x plus 3 times x minus 3. And we're going to zoom in to values closer to 7. All right. So what best models this function? That looks to do it right here. Well, we have the same similar pattern for the let's see, we have the point here 5, -2.25. 5, well, that's a little bit lower. If we look at this one, 5, -2.25. Okay, that's one way to approximate our answer and submit. I got it right. Let's go to question 11. All right, need to factor vertical asymptotes. Let's just do 3x and x. Minus 4 plus 4, yeah. X minus 4, 3x plus 4. That's -12x plus 4x is positive 8x. Over 2x and x. Multiplies to 15, so let's do, that would be x minus 5. 2x times -5 is -10x minus 3. -3 times x is minus 3x. -10x minus 3x is -13x. So our vertical asymptotes, 2x minus 3 is equal to 0. 2x is equal to 3. X is equal to 3/2. And x minus 5 is equal to 0. X is equal to 5. Three halves and 5. And horizontal asymptotes, highest degree coefficient is 3, highest coefficient is 2. Degrees are the same, so that's y equals to 3/2. 3 over 2. All right, that's right, 12. All right. Find the horizontal asymptote of this one right here. Here, our degree is higher in the denominator. If your degree is higher in the denominator, your horizontal asymptote is y is equal to 0. Classified as discontinuities. You have more x plus 4 terms in the numerator than the denominator, so you completely cancel out the x plus 4 terms in the denominator, creating a whole at x equals negative 4. You have more x plus 1 terms in the numerator than the denominator, so you have a whole at x equals negative 1. You have more x minus 1 terms in the numerator than the denominator, so you have a whole at x equals positive 1. And then you have more x minus 2 terms in the numerator than the denominator, so you have a whole at x is equal to 2. So wholes all around. Question 14. We need to find our solutions. Notice that this factors into x plus 3, x minus 1, okay? So that's equal to 8 over x plus 3, x minus 1. And 8x plus 3x minus 1 plus negative 9 over x plus 3 times x minus 1 over x minus 1, get a common denominator here, is equal to x plus 1 over x minus 1 times x plus 3 over x plus 3. This gives us a common denominator. And to cancel the common denominator, knowing that x cannot equal 1 and x cannot equal negative 3. So keep that in mind. So you have 8 minus 9x plus 9 is equal to x plus 1 times x plus 3 is equal to x squared plus x plus 3x plus 3. So that's going to become negative 9x plus 17 is equal to x squared plus 4x plus 3. So 0 is going to equal to x squared plus 9x plus 13x subtract 17 minus 14. This will factor into two values that multiply to negative 14, add to 13, are going to be x plus 14 and x minus 1. And so x plus 14 equals 0, x is equal to negative 14, that's a solution. And x minus 1 equals 0, x is equal to positive 1. So our solutions are x is equal to negative 14, x is equal to 1. Wait! X cannot equal 1. That makes the function undefined. You cannot have the function be undefined. The only solution is x is equal to negative 14. So negative 14 is a solution. What do you mean I've already submitted this page? I haven't submitted this page. Okay, got it right. My open math is glitching. All right, question 15. Solve for x. 4 over x minus 4 is equal to 1 over x plus 5. Get a common denominator. 4 over x minus 4 times x plus 5 over x plus 5 is equal to 1 over x plus 5 times x minus 4 over x minus 4. So this becomes 4x plus 20 over, x plus 5 x minus 4 is equal to x minus 4 over x plus 5 times x minus 4. So once again, cancel everything out, knowing that x cannot equal -5, x cannot equal +4. And so we have 4x plus 20 equals x minus 4. 3x plus 20 is equal to -4. Subtract x from each side. 3x is equal to -24. Divide each side by 3. X is equal to -8. -24 divided by 3 is equal to -8. So our solution is -8. That's not restricted. Got it right, 16. All right. This factors into x plus 3, x minus 1, by the way. That's 8 times x plus 3, x minus 1, plus -9 over x plus 3 times x minus 1 over x minus 1, get a common denominator, is equal to x plus 1 over x minus 1 times x plus 3 over x plus 3. Let's get a common denominator. 8 minus 9x plus 9 is equal to x squared plus 3x plus 4. So x squared plus 4x plus 3. Cancel these out with the understanding that x cannot equal -3 and x cannot equal +1. X squared plus 13x. 3 minus 9 is -6. -6 minus 8 is -14. X, this is looking very familiar to me. X plus 14 x minus 1. So x is, set these equal to 0. X is equal to 1. X is equal to -14. But x cannot equal 1. So x cannot equal 1. So x is equal to -14. -14. Got it right. Question 17. All right. 5 over x plus 1 minus 3 halves is equal to 2 over 3x plus 3. Get a common denominator, so we only want 6x plus 6. 2 over 3x plus 3 times 2 over 2 is equal to -3 over 2 times x plus 3 over x plus 3. 5 over x plus 1 times 6 over 6. So this gives us 30 over 6x plus 6 minus Wait a minute. 6x plus 6. This is just, so this is just going to be, this is not going to be x plus 3. This is going to be 3x plus 3. Three x plus 3, 3x plus 3. So 30 minus 9x plus 9 over 6x plus 6 is equal to 2 times 2 is 4 over 6x plus 6. Now you have a common denominator, cancel it out. You have 30 minus 9x plus 9 is equal to 4. Negative 9x minus 9 plus 30 is equal to 4. Negative 9x plus 21 is equal to 4. Negative 9x minus 17, it's negative 9x is equal to 4 minus 21. That's going to be negative 17. So x is equal to 17 ninths. What an ugly number, but it is. Solution, x should be equal to 17 ninths. Got it right. All right. Determine the vertical asymptotes and holes, removable points to discontinuity rational function shown below. Holes x minus 10, that cancels out. So x minus 10 equals 0. X is equal to 10. That's a hole. And then x minus 7 equals 0. X is equal to 7. It's a vertical asymptote. And that's because it doesn't cancel out. Holes cancel out, vertical asymptotes don't. That's right. Move along. Question 19. The domain is, well, let's look at our restrictions here. Vertical asymptotes, nothing cancels out here. So you have x plus 5 equals 0. X is equal to negative 5. And 2x plus 3 is equal to 0. 2x is equal to negative 3. X is equal to negative 3 over 2. So vertical asymptotes are x equals negative 5 and x equals negative 3 over 2. Okay, and from those, we don't have any holes, so just from those vertical asymptotes, we know that our domain is from negative infinity to negative 5 union negative 5 to negative 3 over 2, negative 3 over 2 union negative 3 over 2 to infinity. Okay, The y-intercept is the point where the y-intercept is the point where the x values are equal to 0. So when your x values are equal to 0, this x value is 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 0. So actually, this might be easier to value this. This x value is 0, this x value is 0, this x value is 0, this x value is 0. So you have y is equal to -2 times 4 times 4 over 5 times 3. So that's 16 over 15 times -2. So that's -32 over 15. All right. Y-intercept is the point 0, -32 over 15. The x-intercepts are the value when y is equal to 0. So the x-intercepts is the value when y is equal to 0, and if y is equal to 0, then 0 is equal to -2 times x plus 5 times 2x plus 3 over x plus 4 times 3x plus 4. And what I do is I multiply each side by this value. So I multiply the right-hand side and the left-hand side by that value. Cancels out here, multiplying by 0. So now I have 0 is equal to -2 times x plus 4 times 3x plus 4. And divide each side by -2. 0 is equal to x plus 4. 0 is equal to 3x plus 4. And -4 is equal to x. -4/3 is equal to x. So our x values are the points x are -4, 0 and -4/3, 0. -4, 0, -4/3, 0. Horizontal asymptote, degrees are the same, 3/2. Y equals 3/2 horizontal line. Multiply that by -2. That should be y is equal to 6/2. That's what they want. Vertical asymptotes, we have 1/2 and 5/2. Domain is from -infinity to 1/2 union 1/2 to 5/2 union 5/2 to infinity. All right, the y-intercept, that's the value when x values are 0. That's going to be 16/5. 0. So sorry, 0 16/5. So x value is 0, and our y value is 16/5. The x-intercepts, those are the values when y is equal to 0, so that's going to be x plus 4, so that's going to be negative 4, 0, and 3x plus 2 is equal to 0, so that's going to be negative 2/3, 0. All right. Horizontal asymptote is 2 times 3 is 6. 6/4. That's going to simplify to y equals 6/4, 3/2. Y equals 3/2. All right, that's everything. Question 20. All right. Solve the rational equation. Enter any solution that checks as an integer or a reduced fraction. Separate with commas if there is more than one solution. If there are no solutions, click the no solution button. So we need a factor. This is, by the way, this is x minus 8, x minus 5. So we have negative 7x plus 80. That's already factored. That's equal to 6 over x minus 5 times x minus 8 over x minus 8. All right, so that's, let's say negative 6 times x minus 5 times x minus 8. Here, it might just be easier if I do this in order. Easier for me, easier for you. Wait to load. X over x minus 8 times x minus 5 over x minus 5 minus 6 over x minus 5 times x minus 8 over x minus 8. Evaluate the common denominator. Negative 7x plus 80 is equal to x squared minus 5x minus 6x minus 48. So that's going to become 7x plus 80 is equal to x squared minus 5x minus 6x plus 48. So then we this is going to be equal to x squared minus 5x minus 6x minus 11x plus 7x minus 4x plus 48 minus 80. It's going to be minus 32. That's equal to 0. So that's going to be equal to 8 times 4. 8, yeah. X minus 8, x plus 4. So x minus 8 is equal to 0. x is equal to 8. X plus 4 is equal to 0. X is equal to negative 4. But x minus 8 is in the denominator, so x cannot equal 8 and x cannot equal 5. So this is not a solution. The only solution is x equal to negative 4. Got that right. 21. Solve the rational equation. All right, you have s squared minus 49 plus s plus 7 is equal to s minus 7. So you have negative 6s times s plus 7 times s minus 7 plus 10 over s plus 7 is equal to 1 over s minus 7. Sorry. S minus 7 over s minus 7. You have so I'm going to multiply this by s minus 7 over s minus 7 to get a common denominator. So I get negative 65 plus 10s minus 70 is equal to s plus 7 over s plus 7, s plus 7. Now, remember s cannot equal 7 and s cannot equal negative 7. So, getting this all on one side, nine s is equal to negative 135. Sorry, 9s minus 135. So just subtract s from each side. Is equal to 7. And then add 135 and you have, add 135 to each side and you're going to get 142. 9s equals 142. 142 divided by 9 is 15 point. Let's math frac that. Okay. So you have s plus 7 is equal to 10s minus 70. Oh, that's negative 6s. Okay, that's why. That's not. That's not negative 65. That's negative 6s. So negative 6s plus 10s. So that's going to be 4s minus 70 is equal to s plus 7. 3s is equal to 77. So 77 divided by 3 is 25. Can we that can't be simplified. So s is just equal to 77 over 3. 77 thirds. That's right. Question. 2 over 3x plus 3 times 2 over 2 is equal to 1/2 times 3x plus 3 over 3x plus 3 minus 8 over x plus 1 times 6 over 6, and I get 48 over 6x plus 6 minus 3x plus 3 over 6x plus 6 is equal to 4 over 6x plus 6. Give me a common denominator. Cancel out that common denominator. 48 minus 3x minus 3 is equal to 4. 45 minus 3x is equal to 4. Negative 3x is equal to, subtract 45 is equal to negative 41. So x is equal to negative 41 thirds. All right, that's what I'm going for. All right, I made an algebraic mistake there. I'm going to try again. Okay, multiply this by 2. 16 is equal to, multiply this term by 3x plus 3. So that's going to be 3 times 3x. That's going to be 9x plus 9. And multiply this by 6 over 6. So that's 7 times 6 is 42. 42 minus 9x plus 9. So that's going to be negative 9x minus 9 plus 42 is equal to 16. So that's going to be negative 9x plus 40. 40 minus 7 is going to be plus 33 is equal to 16. So negative 9x is equal to, wait, that is 7. 40 minus 7 is 33. That's right. So 16 minus 33, that's going to be negative 17. So x is equal to 17 ninths. All right, didn't make a mistake that time. Question 23. X over x minus 1 minus 8 over x plus 4 is equal to negative 3x plus 50 over x squared plus 3x minus 4. Get a common denominator. X over, so just you just multiply. So I'm just going to show you the way I do it when you know what's going on. X times x plus 4 minus 8 times x minus 1, whole denominator here, is equal to negative 3x plus 50. So x squared plus 4x minus 8x plus 8 is equal to negative 3x plus 50. X squared minus 4x plus 8 is equal to negative 3x plus 50. X squared minus x minus 42 is equal to 0. So 7 times 6 is 42. So that would become x minus 7, x plus 6 is equal to 0, which means x is equal to 7, x is equal to negative 6. So our solutions would be negative 6 and 7. Those are correct. 24. All right. Determine the vertical asymptotes and holes, removable points of discontinuity of rational functions shown below. Use commas to separate the results. So nothing cancels out, so there's no holes. The vertical asymptotes are just x equals negative 2, x equals positive 1. Negative 2. $25. Horizontal asymptote, the degree is larger in the denominator. If that case, the horizontal asymptote is always 0. All right, that's the video.